What's going on, you guys? So today we're going to do implement strStr, and so the idea behind this is we'll have a haystack string and a needle string, and if we find the needle string within haystack, we want to return the index where it starts. So in this case, we find LL here. The first L's index is 2. So in this one, we're checking for BBA. So we loop through the whole string and we do not find BBA, so we return a -1. In this case, we're defined, if needle is an empty string, we're just going to return 0. So, okay. So let's think about this. So we know this. If needle is an empty string, we'll just return 0. We got that one. That's pretty easy. What else? So let's think about hello. Right? So what we can do is we can create a sliding window. It's the size of needle. So in this case, 2. And we'll check each one and see if it's equal to needle. So we'll say, does HE equal LL? No, it doesn't. So we'll move 1 over. Does EL equal LL? No. Okay. Does LL equal LL? Yes. So return the index of the start position, which would be 2 in this case. So, and let's do another example where we do not find it. So here. Okay, so we have a window that's the size of needle, so size 3. So we'll start at the beginning. Does AAA equal BBA? No. Okay, so move over 1. Does AAA equal BBA? No. Okay, so move over 1. Okay, we've reached the end. AAA equal BBA? No, and we've reached the end, so we're going to return -1. Okay. Also, what about this one? What if haystack equals hay and needle equals haystack? So needle is greater than haystack. Well, we can't create a window that's big enough, so we'll return -1 in that case. So if needle.length is greater than haystack.length, we'll return -1. Okay. So the question is, how do we create this sliding window? So we're going to do a for loop. And so what's the condition going to be? We'll come back to the indexes. So we'll say that we'll call our index I. So what happened here? So if the window is equal to needle, then we want to return the current index we're at. Right? Okay. So if the window, so our window will be haystack.substring from I until some value. I until some value. If it equals needle, then we're going to return true. And if we get to the end and we do not find a equivalent window, then we'll return false. Here's the interesting part. Like, what are the indexes here? What's the end index for haystack.substring, and where is I going to be going? So substring will return an index out of bounds error if we give anything greater than haystack.length. So that has to be the maximum value, right? So the last value we get here has to be the last value in haystack. So let's call this, so we know it's going to start in 0. I will start at 0, right? Like when we do hello, our first window will be here, right? So we know I starts at 0. Where does it end? Until end. We'll call this, let's call this y. Let's call this x for now. Okay, so how is x related to y? So we want the final value, let's see. Now let's do, so so the last value I will take is x minus 1. So this is a little confusing. So let's do an inclusive range. So the last value here is equal to x. So x plus y has to equal haystack, that length. X dot y plus x has to equal haystack dot length. Okay. So in this case, let's look at some examples. Okay. In this case, x plus y equals haystack dot length, which is 1, 2, 3, 4, 5. Okay. So in this case, this is haystack dot substring 0, 1, 2, 3 to 5. 0, 1, 2, 3, 4. Okay. Okay. And what about this case? This is haystack. Let's copy this. Copy. Okay, this is haystack 0, 1, 2 until 0, 1, 2, 3, 4, 2 to 5. Okay. All right. Let's clean this up a little bit. Let's call this h and n. H length equals 5, n length equals 2. Okay, h length equals 5, n length equals 3. Okay. So h length minus n length is the last value that I will take. 5 minus 2 is 3. 5 minus 3 is 2. So let's set x equal to, let's call this end. Call this end. Say var end equals haystack dot length minus needle dot length. Substring, it goes from I until I plus needle dot length. Right, so the last value, so when end equals 3, 3 plus n dot length is 5. Okay, cool. All right, let's see if this works. Oh, we want to return the index where that happens. And if we get through this and we do not find a match, we're going to return -1. Okay, you guys, so the key to this question was to work through examples just by hand, you know, by moving our sliding window by hand. We're able to see that there's these conditions on the beginning index and ending index for our substring, or which is our sliding string window. Yeah, and just doing a little bit of math that helped us figure out, you know, our last value is going to be haystack.length minus needle.length. All right, you guys, that has been, oh, and let's think about space and time complexity. Okay, space and time, so this is basically, it's going to loop through each, that it like n minus some constant comparisons it will do, but that's basically just O of n, time complexity, and space complexity. Let's see, just O of 1. We're not storing any variables anywhere. We could even get rid of the end variable if we wanted to. Okay, so O of n space time complexity, O of 1 time, O of n time complexity, O of 1 space complexity. All right, guys, that has been implement strStr. See ya.